Okay, I'm going to share with you a few thoughts on this task then and why I like it. So I actually used it a couple of days ago with Year 9, and I gave it as a kind of do now task as they came into the classroom. So those who had their calculators, who'd remembered their calculators, quickly started doing 28 times 66 times 15 to find the volume of the first cuboid, which is 27,720. And then because these cuboids have the same volume, they decided they needed to divide by 18 times 22, 396, and that will give you the missing side length of 70. So you can imagine that was all done and dusted in about a couple of minutes by the time I'd taken the register. And then, as always, what I like to do now is try and draw links with other topics. So in this case, it's prime factors. And I said, is there another way that we could have maybe worked this out? If you didn't have your calculator, or if you didn't want to do any long multiplication or divisions, could we have worked it out without having to do any hard calculations at all? So the clue's in these prime factorizations here, the fact that 28 is 2 times 2 times 7, and can we do that to the other dimensions of the first cuboid? So 66 would be 2 times 3, which is 6, and then times it by 11. And then 15 would just be 3 times 5. And then we checked at this point that this huge long list of numbers here still gives us this product of 27,720. Then we said, okay, what if we do that to the other dimensions, and what do we know? Well, we know they have the same volume, so if we do the same to the 18, now 18 is 9 times 2, so that's going to be 2 times 3 times 3, and the 22 is 2 times 11, then what's left must be the missing question mark. So they said things now at this point, okay, we need to just like sort of mix and match numbers from the top and the bottom, so kind of cross out numbers from the top and the bottom, and then what we're left with must be the question mark. So you can see we're going to find the answer without doing any large multiplications here. So we'll cross out the 2's, another 2 there, we've got a 3 there and there, a 3 there, and then we've got this 11 as well. So what we're left with, the difference between the two rows, is in the top row we've got 7 times 2 times 5, and on the bottom row we've got the question mark. But crucially, we know that these two products are equal because these cuboids have the same volume. So the question mark must be 7 times 2 times 5, which gives us the same answer of 70. And they really liked it, and it helped them draw those links between prime factorisation and the volume of a cuboid as well. Then we spent about another 10 or 15 minutes maybe on part B of the task, which was how many different cuboids with integer lengths have the same volume. So it's a case of once you know this large prime factor, this large list of prime factors, it's a case of taking a set of 3 different products to find a different cuboid which has the same volume. So it's a lovely little task. I do encourage you to try it out in the classroom, and please do let me know your thoughts.